Hello there, and welcome to this, the Developer's Guide for Windows 10 Preview MVA.
The Developer's Guide for Windows 10 Preview. That's right, because we're just past build. A lot of exciting things have happened. That's what we're going to be covering today.
Yep, and at build we released a pretty complete version of the Windows tools for building apps for Windows 10, and we're going to be taking you through those and showing you the kind of cool stuff that you can do with that. I'm Andy Wigley. I'm a developer evangelist working for Microsoft DX Developer Experience Group. And with me?
I'm Jerry Nixon, and like my friend here, Andy, I also work in evangelism, and I live in Colorado. Andy, I know you live in the UK, and we teach on phone and Windows and XAML and Microsoft constantly, and so this is pretty exciting.
It is. It is.
It is exciting. All right, so here we are, the Universal Windows Platform. Now, the name has changed. We had a series of sessions when this was preview. You remember that? And it was the Windows Application Platform.
UAP.
So we changed that to the Windows Universal. So as names change, we've got a new title for this session. And so this is building a modern, remember we used to call them modern?
Yes.
Fully immersive, then we referred to them as immersive for a while. Windows apps, now that is what we actually call it. For the Windows Store, there were Windows Store apps for a while, that was great. Targeting the common universal Windows platform, which is true, that is actually what we're doing. And so this is the definitive developer's guide for Windows 10 Insider Preview.
Can I summarize that? So what we're going to be talking about is the premier native technology for building apps for the Windows platform. We are going to talk about a lot of the other different ways you can build apps for this platform as well. But we're going to be focusing in this MVA primarily on all the cool things you can do with the platform, but from a UI perspective on XAML and C#.
That's right. We will not be talking about naming conventions anymore. That was just for fun. What will we be talking about in this session? Well, specifically we're going to be talking about the fundamentals of Windows 10 and this new platform that we're going to be building against. So we'll talk about this single platform, and we'll talk a little bit about the developer experience, some of the tooling and some of the cool things that are coming to us. And then we'll also introduce the template that we'll be using as the base for all the demos that we'll be putting together.
Yeah, we've built a lot of cool stuff into the template, which make kind of the basic, simple stuff easier.
That's right.
So we're using that as our foundation.
So let's start off with the introduction to UWP. So UWP, the Universal Windows Platform, and we'll begin there. And it all starts at the very beginning. It's a very good place to start, Andy. And we're going to start at Windows Core. Windows Core, once upon a time referred to as One Core, I think in some previous sessions we may have done. Yep. The Windows Core is the refactored common core of Windows. That this has been a process that's been undergoing for many years, where Windows is going through, and finally we've reached a point where what we install on an IoT device, what we install on a phone, what we install on desktop really is the same version of Windows.
And wider than that, Xbox and the big Surface Hub and even the holographic headset.
That's right. Yeah, I mean, I think it's fair to say everything that is a Windows 10 device is running this Windows Core. Yeah. Now, the graphic kind of illustrates it a little bit. So we have the device itself under, and then Windows Core is there as a layer. But it's not enough. We know that the Windows Core doesn't implement all the features, let's say, of holographic, right? Or certainly not of the desktop or the phone. And so there is an addition to the Windows Core that creates the individual SKUs.
So SKUs, for those, that's a stop-keeping unit. But basically what we're talking about is a product.
Yes.
A Windows 10 product here. So phones, tablet, PCs, Xbox, as you got there. So
a tremendous value to this is from the hardware point of view. And if you were going to write a hardware driver for the next widget you create, whatever that is, back in the previous Windows days, you would have to write many different drivers to make sure that you hit all the variants. Now that there's one, we have this idea of a universal hardware driver that we didn't really have before. So now an ARM 64 and 32-bit is all you'd ever have to compile to and be ready, and you've got it there. There's just a lot of benefits to the Windows Core. And from a developer's point of view, one of the benefits is fundamentally the operating system works the same everywhere, including things like I/O and stuff like that. Brilliant. Well, this is an exciting slide.
Yeah, so this one represents very nicely our different, at the moment anyway, the different Windows 10 products, if you like, that we have. So
7. I'm counting 7 bright purple boxes.
That's right. And of course, there'll be more to come, because the beauty of having this one core is that we've got this now solid foundations for future products that we haven't thought about. Clearly on the right there, the holographic, the HoloLens is kind of one of the brand new kids on the block. And in the middle there, IoT, the Raspberry Pi 2, this tiny little maker board for like, what is it, 30 bucks?
Yeah. It's great.
Even that can run Windows 10, the same one core. So here we got desktop. This is a nice way of thinking about all the different Windows 10 products we've got. Desktop means your PCs, your large tablets, convertibles, that kind of thing. Mobile is phones and small tablets. Xbox is, of course, Xbox.
Yeah, that's right.
And then we've got the IoT flavors. The Surface Hub, the big, it's like huge wall-mounted.
Used to be called PPI.
Yep.
Yeah.
And then the HoloLens. And you can see there the green ones is breaking those down underneath into
kind of what would be there, what's there today.
Yeah.
What do you think the next one's going to be? The next purple box?
Well, who knows? Yeah.
That's exciting.
Yeah, Microsoft.
Airplane?
Yeah, airplane. I think so.
Yeah,
airplane.
Nothing scary about that.
No. Yeah, who knows? But yeah, there'll be more. There will be more.
All right. What we do know is that as we inherit from the base, right, as Windows Core comes to us, every family or every device group is adding on the features it needs to make it. So, for example, I think it's good just for a second to go back and talk about holographic. And so we're creating a holographic version of Windows, and HoloLens uses it. What we aren't creating is a HoloLens version of Windows. And so right now there's only HoloLens under that, but there could be another type, and just as we could add as many green boxes as we wanted to this. So I think that's an important kind of takeaway.
But from a developer point of view, actually another important takeaway is those purple boxes there, those are discrete device families, and all of those device families have a commonality about them from a developer point of view. So when you're building apps for Windows 10, you are targeting one of those device families.
That's right, and it's that one Windows that makes it a reliable experience. But there's another layer, and we'll talk about that here in just a second. Okay, so this is the convergence story that we kind of have come to, and so let's step back a long way, back to Windows Phone 7, which 2000.
Well, in the midst of time, 2012.
Time immemorial. Yeah. We had Windows Phone 7 came out. It was a completely different operating system. Meanwhile, we had Windows Mobile, and that was a completely different operating system. Xbox 360, completely different operating system. No convergence at all back then.
They had obviously commonality. So yeah, the phones in those days were running Windows CE, so which is our small, lightweight operating system for handheld devices. It's still our only real-time operating system. So it's a great operating system, but it was a different branch of the Windows family from the Windows NT kernel stuff that we had on PCs and again Xbox. They'd all go back and they'd all diverged and had been plowing their own furrow for quite a while.
I knew you'd say something nice about Windows Mobile like that.
Yeah, it's where I come from. Yeah. Yeah. And then, by the time we got to Xbox One, Windows 8 and Windows Phone 8, now this convergence was starting to kick in. You see that the train tracks are getting closer together there.
Right.
So all of those now, when we shifted from Windows Phone 7.5 up to Windows Phone 8, we actually ripped out the whole OS underneath it and put in the Windows NT kernel.
It's a very small piece of the track there going from Windows Phone 7 to 8. But it's a big engineering effort that went on.
It was a huge engineering, and it was putting the foundations in that have led us to the beautiful converged situation where we are today with Windows 10.
So that was the convergence of the kernel, which certainly wasn't enough, right? No. That was just the beginning and allowed us to have things like multi-core and our multitasking.
Yep.
But then we move on into Windows 8.1, and we introduced for the first time an app model convergence where a developer had a similar but not identical experience across phone and Windows. That was really nice.
So very close. So that was, so Windows Phone 8, Windows Phone 7.5 before that, you were building XAML-based apps, but they were using our older Silverlight technology.
Yeah.
It's still very popular. You can still write apps with that today, and they'll run on all our current devices. So it's still great.
Yeah, back with 360, we could say things like, look at how similar it is to use all the Microsoft versions of Windows. And then we go to Xbox One, we're like, and there really are Windows in the inside. Now all of a sudden we have this story for developers, your experience is so similar, and then magically, we hit nirvana, this golden season that we're in today.
Yeah.
Windows 10.
Windows 10, which is now the truly converged, not only at the operating system level, but all the way up the stack, and now it is a truly converged developer platform.
Yeah, just a year ago, we were teaching things like this is what you can do on Windows and this is what you can do on phone. We don't teach that anymore because now it really is just one, and it's all the way across. And we'll talk about how that's accomplished here, right now. This is sort of a sampling or just something to get your feel for just the breadth of devices supported by Windows.
Yeah, that's right. So here we can see all the different, right from small 4-inch phone displays right through phablets, up to bigger screens, the 2-in-1s where you can, like the Surface Pro, where you can remove the keyboard, classic laptops, and all the way through to 84-inch Surface Hubs, and the Xbox, of course, the holographic, and right down to the tiny little board. So very diverse.
Let's think about what it means here then around for the developer.
Yep.
So we have several families. Let's see here. For example, IoT, we bring in IoT. All of these group together to make up the mobile SKU and what's supported by it. The PC and the Xbox are there. Each of these are when we say family, device family, this is what we mean. We mean the grouping of the devices, but also the Windows SKU as well.
Yeah. Now, when you are building an app for Windows 10, you are targeting one or more of these device families. And that's a one sentence summary of this whole MVA. Really, is what we're going to be talking about.
It is, and we'll know soon that it's the Windows platform that allows us to do that. But it's nice that you said one or more rather than all. But because I think the accidental message that people are hearing is that I'm writing an application, and man, it's going to be a lot of work to make this work on the Surface Hub.
Yeah, that's
well,
right.
It doesn't have to work on the Surface Hub, and that's sort of the goal. So underneath this, even though I have the Universal App Platform, I also have a series of services and capabilities that are unified across all the devices. Things like inking. I can ink everywhere I want to. It's not a special API just for mobile. It's not a special API just for HoloLens.
Yeah, and it's one SDK, so we're just using one tool set, one set of APIs to build apps for right the way across all of these different device families.
So the UWP, the Universal Windows Platform, there's a level to that everybody gets. So they only get one SDK. That's it, and then of course they can compound that, and we'll look at how that's accomplished. So that UWP is what we would refer to as, or kind of describe as, a single API surface. So these are the APIs that I know are reliable and are guaranteed to me no matter what device I'm running on, as long as I target this platform. So this is totally new. It used to be, think back to Windows Mobile days, I was writing an application, namespaces were even slightly different sometimes. And so in order to get things to work, you would have to pay attention to it. Now you're really not. You're building to a single set of APIs that are guaranteed to you.
So it's guaranteed. So yeah, the images on that slide of the kind of Windows Explorer images, which you can see there, it just allows you to drill down into Windows program files, x86, Windows kits, 10 platforms. It's still called UAP currently with the current set of it. And then you've got a version under there, which at the time that we're recording this is 10.0.10.069.0. So, and that keeps getting revised as we are building the product and until we get to the final release. And inside that folder, all you'll find is a little XML file,
which truly is the definition of this platform. This version of it.
And opening that up, that platform.xml, you can see it just has the name of the application platform. It's called Windows 10 Tech Preview, has the version, and inside it has this element, contained API contracts.
Yeah.
So what is an API contract?
Well, it's a WinMD file. That's really what it is, right? And those WinMD that's a metadata file that exposes underlying APIs in a reusable way. So when I look at a contract, I'm really looking at a facade of other APIs.
And it's a contract because what we're saying is that, look, this is a versioned, guaranteed API surface. So version 1 of the windows.foundation.universal API contract. This is it, and you're building against this. Now, it will be revised fairly frequently, so we're going to have updates to this and new versions.
Will it be revised, or will there be siblings added to it?
Well, both. Both, in fact. Yeah.
So right now we can see the one we're looking at is version 10.0.10069, and it's made up of those 3 contracts, but not just those 3 contracts, those 3 contracts at that version number.
Yep.
That's where it becomes a guarantee to the developer.
Yep.
This set of APIs and their version numbers are the same on HoloLens, they're the same on IoT, they're the same on phone, they're the same everywhere.
Yep.
And in a way, because it's like this, right, it's not a gigantic DLL that makes up the platform. It's really just a description of all the things that it's going to provide. It makes it so we can compose platforms very easily. So if the next platform needs to roll in another DLL or a WinMD, right? Then it just does, and it just defines it here, and then it's up. Of course, it's up to the operating system to make sure that those are actually available on all the devices.
Yep.
But once it shows up, that's basically Microsoft saying it is available on all the devices. You can trust it. Go for it.
Now, I heard them say at Build that in this universal platform, you would tend to find around in excess of 85% of all of the APIs that you're going to want to use in your apps. Now, that's kind of a figure plucked out of thin air,
Andy,
because it depends.
In my experiments, I've found it to be 86%.
Okay.
It's better than they said.
86. You heard it here first. Jerry says it's 86.
Yeah, something like that.
But the point is, it's a very high percentage of all of the stuff you're going to want to do in a typical app, whatever that is. But most of it you're going to find in this universal API set. There's some edge cases where we extend it out to do different things on different device families, and we're going to walk you through that and show you how that works. But essentially, this the universal guaranteed API surface is common across all Windows 10 devices, and this is what you're coding against. And for those of you, sorry, I was going to say, for those of you who are wondering, thinking, wow, this all sounds a great, wonderful new world, what we're really talking about here is the WinRT API set. So if you've been building apps for Windows 8.1 or Windows Phone 8.1,
glad you said that.
It's the same stuff.
That's right.
It's the same stuff. It's a repackaging, a reimagining of it, a new way of handling versioning of it, because we are moving to a new world where the developer platform, the devices are all going to get revised more and more frequently.
I could imagine a developer listening to this and say, oh boy, I just learned all the old namespaces and how to do the stuff, building out Windows 8 applications, and now everything's been changed. The reality, of course, is everything hasn't been changed. This is a superset of what you've already been doing. The same approaches, the same namespaces, everything is still there.
Yep.
It's just exposed now through UWP. So in the past, you would create an application, you would target Windows 8.0, or you would target Windows 8.1, and then it would run on it. If you target it for 8.1, it wouldn't run on 8.0. And then as we move forward, you would target the operating system, and that's not the way we're going to do it from here forward. We don't target the Windows 10 or the operating system in any way. We target instead the platform. And so again, we saw that version number that we're targeting. That's what we do. We target a specific version of the platform in our apps, but not just one version necessarily.
And it's probably, so that's a really important point. So in the past, we used to have these big Windows releases every few years.
Yeah.
A big new version came out, and of course we'd have a new version of .NET would come with it, and there was everything was all tied together on this release cadence.
Yeah.
So now we're breaking that connection and making it much easier for us to ship updates and get new APIs out to you, new stuff out to you, much kind of out of band. We used to talk about out of band. So out of band is the new normal. It's just going to be stuff getting revised all the time, which allows the platform to innovate faster. It allows you as developers to add cooler stuff to your and new features to your apps faster.
It sounds like it may just be endless and unmanageable change, but what it really is a kind of it allows us to see operating systems and devices upgrade more easily.
Yep.
So instead of these giant monolithic sort of things that when are you finally going to install Service Pack 2, really you've just installed several different updates that just kind of trickle out through the months.
Yep.
That's the idea. So here is an example of how we might be able to target the platform. But again, we don't target just a version. We can target a range of versions. So that, let's pretend the platform has been released every month for the last 6 months, and every single release is pretty neat, but it doesn't really apply to my application. That doesn't matter. I've gone ahead and tested, making sure that it works. And so I can create a range to say anywhere between a long time ago and now, it works just fine. And even then, I can test inside it to say the new ones actually have extra features. I can light up my application with those.
What we're saying here with that min version equals, we're saying that this app that I've created was built against that version, will run on devices running that version, but won't run on earlier ones.
That's right.
But the max version test is saying, well, yeah, we're giving you a loose guarantee that it's going to be all right on version 10.0.10190, which we haven't had yet, but presumably be out there next week, I think.
We're forecasting that.
Yeah, we are forecasting that one. So. And it may well run on higher versions than that, but you as a developer are saying, we require a min version of 10.069, but we will think it will work just fine on versions up to. We've tested it.
Can you imagine the complexity around the store? I don't know what apps it can show you and not show you. Aren't you glad you're not on that team having to write that?
The store is, it's very interesting.
That's magical.
Yeah.
All right, so around the whole thing here is the ability to have its own cadence around updates. That's important so that we can know. And since they aren't these gigantic platform updates, they can do these small things, so we can take advantage of them and have a better experience of knowing that they'll be on devices. Okay, so then we've talked about the Windows core. We've talked about the universal Windows platform. Now let's talk about the Windows app, the thing that we're building, and how this is different from Windows 8. So when I would build, let's say 8.1, let's say, when I was building a universal app for Windows 8.1, it had the quality of two heads, right? I would practically be building two applications with a shared project in the middle. And I would compile a binary specific for my phone, and I would compile a binary specific for my desktop, right? They were really two different applications, just sharing a lot of code. That's not where we are today. We're at a single binary, Andy, a single binary that runs across everything. And from a developer's point of view, I mean, obviously they can constrain it, but if they don't, it could be running anywhere. You never know where your application's going to run.
So at a theoretical level, we can create one app package that could run right on a Raspberry Pi 2, right through to a HoloLens.
Yeah.
Now, actually, I can't think of many use cases where you probably would want to do that, but at a theoretical level, you could in fact actually do that. So, because it's the same binary, it's the same app platform.
Yeah, that's right. So that's the upside. The upside is I'm always writing an application, and I'm always writing that application for the Windows platform, knowing it'll run wherever I want it to. Then as a developer or a designer or a publisher or whoever you are, you get to constrain that down to the device families that make sense for your application.
Indeed.
That's exactly right. Okay, well, the developer story here, just to be clear, is when, if I'm writing an iOS application, I really get two benefits out of that. The first is it goes to iPad and iPhone. If I'm writing an Android application, I'm writing to all the supported devices, and I'll put that in quotes.
And in fact, they have a similar to our range of min version tested to max. That's the similar thing with Android. You might support a range of versions of Android from your app, so we're in a similar place.
Well, it sort of makes it so Android developers might even feel comfortable with this, as they come in, and we'll talk about. There's a lot of things to give them some comfort food. So when we were writing Windows 8, it was for each device, right? You would have separate. But now when we write for Windows 10, we're basically developing for every device, or better to say, any device that I want to. All right, let's pull up, and I have Blend here, and let's just see how we can put something together. And so this is Blend for Visual Studio 2015. Of course, this ships free with Blend or with Visual Studio. And so we'll just create a blank application and just show some of the basics of Blend that have always been there.
Yep.
And so this is nice because Blend has been revamped to use the Visual Studio shell. So it has all the features of Visual Studio. It doesn't have all the features of Visual Studio. It has all the relevant features. So for example, the features of Blend are creating sample data. So I can create new sample data. This has always been in Blend to be able to do this. And once it's there, I can drag them onto the design surface. And Blend, because it's Blend, it knows exactly what I'm trying to accomplish. And as a XAML developer, Blend now is a place I can go and live in much longer because I have full IntelliSense and things like that I didn't have before in Blend, that I had to go back to Visual Studio for. Now I have really, this could be where I spend a bulk of my time rather than just a portion of my time doing significant UI. All right, so this is me running it on the desktop.
Yeah.
And you can see it went ahead and created there's a list view of all the chairs. That's pretty iconic. It's always been there, hasn't it? And then I can flip through the lorem ipsum titles for a pivot control. All of the controls now, of course, since you're building a single binary for every device, all of the controls are converged so that they look great on every device, which means sometimes they have to do some magical things so that they support, let's say, mouse and touch real easily. So this is my phone emulator. It's deploying the application up and running it for me. Again, it won't make any changes to it because there's no reason to make changes to it. You can see I've got my my nice touch-ready pivot as well as the list view inside it. So this is just me kind of showing off how I can build a quick application that's targeting UWP and run it on, in this case, both the desktop and the phone. And if I had the HoloLens emulator installed, I could run it on the HoloLens. If I had, and you just fill in the blank from there, whatever devices I had, they would always run the project. There's only one head in the project. You know, it's only one thing that I'm actually creating. But sometimes that default UAP, that default UWP, that platform layer that's unified and guaranteed across all the devices isn't enough, Andy.
Well, yeah, so it's really important to realize that what we're not talking about here is the lowest common denominator. We're not saying, oh yeah, we can create a single app that runs across everything, but you know that means you're going to kind of have to dumb it down. We don't care very much about having a great experience. Quite the opposite. What we want you to do is create a user experience that really shines on each device and makes the most of each device. And we're talking about, different use cases. The way that somebody uses a phone right in front of their face tends to be short interactions, snatched moments, and then obviously
almost always touch.
Yeah, that's right. And then if you're using a bigger screen, well, it might be a touch screen, or you might be using mouse and keyboard. It might be windowed, or it might be full screen on a large tablet. So we've got lots of different sort of use cases and user scenarios that we need to make sure we really support. And that's where we extend the universal API set with device family specific additions.
So let's pretend you're building an application for the Xbox and you want to interact with, say, the Avatar API, which is unique to the Xbox. Well, that's not going to be in the core UWP API, right? Because that doesn't make sense for those APIs to exist over on HoloLens or somewhere where they don't use those APIs. The same thing with the holographic APIs of HoloLens don't exist on the Raspberry Pi. Well, how do we access those? We access those with the extension SDKs for the platform. So an extension SDK is really a special, it's not like just adding a reference to your project. It really is special, and it is specific to a type of device. Well, in this case, you could always make it a third party will start to create them as well. Or you might have one, let's say, for the Connect that would really apply for multiple devices. But let's say right now it's for the device. So I want to use something that's very specific to the phone, so I would install or I would add or reference the extension specific to the phone. Yep. Right? Now, it's important that we talk about how extensions don't break or invalidate all of the other devices. And so if you have a device and you have an application you're creating and you start writing HoloLens code, and you know that there's a possibility that this will also run on the desktop, and you can light up on the HoloLens, and you can just, what do you, light down?
Dumb down.
Yeah, you don't show those features.
No, let's put this, So you have one experience for a desktop user, and you have obviously a different experience, and a virtual reality experience for the HoloLens user. But it's still one app package, and we've got ways of adapting the code to handle that, and we're going to talk a little bit more about that.
We have a whole session dedicated.
We have a whole session, and we're going to come back to it a little bit later in this session as well.
But the important thing is I can start bringing in features of Xbox, and it doesn't mean I can't run it on the phone anymore. I can start bringing in features of the HoloLens, and it doesn't mean I can't run it on the phone anymore, right? Those are all very important. All right, so this is the Universal Windows Platform, and it gives us a handful of things. It gives us one operating system, which is what we were talking about when we were talking about that one Windows. It also gives us a single app platform, which is that platform we all write to, the Universal Windows Platform. And then conveniently, we also have now one dev center. So that's the place where I submit my application.
So in 8.1, we have actually separate phone and Windows Store dev centers. There's one, you're signed into both. They are quite linked, but they're still physically separate. And now we're down.
You'd look at your dashboard, but you'd have to go to the phone dashboard to see those apps. You'd go, and also for MSDN. So MSDN now is converged, so you don't go to windowsphone.com to get support. You can go just to dev.windows.com.
Indeed, yeah.
And with a single store, well, we'll talk about that, and the single store is going to be pretty incredible. But that's one thing. Of course, how could you have multiple stores? You have to have one store. All right, so one thing that is beautiful is that traditional Microsoft technologies, such as what we're talking about today, XAML and C#, they are not the only way to create a Windows app, Andy. Did you know that?
I didn't know that. I think most of the world knows that. Yeah.
All right, so let's talk about how you get to Windows 8. So this is our path as a developer, and what do we do? So, of course, did I say Windows 8? I meant Windows 10.
Yes.
Yeah. How you get to Windows 8 is a previous session that we've already recorded. The Windows 10 operating system is right there waiting for us, and the first approach is, let's just call it the desktop approach.
Traditional Windows apps.
Traditional
Windows apps.
Classic Windows?
Classic Windows. Classic.
Yes.
CWAs as an acronym. So, yeah, this is, and WPF, still absolutely the premier technology for creating desktop apps.
That's right.
And these, of course, will run only on x86, x64 machines.
That's right. This is not an ARM story.
MFC, C++, very popular technologies, and still absolutely a valid way of creating apps for PCs.
That's right. If I'm writing the check and you're going to run my entire business off of it, I might stop right here. But if I were trying to engage my mobile audience and things like that, I might move over towards the universal Windows platform.
Yep.
And there's several approaches, and these approaches haven't really changed since Windows 8. So, I mean, we're not really introducing a new paradigm here, just kind of confirming that things are still the way that they were. And so instead of the WinRT, which used to be the block where the universal Windows platform is, now we have this new sort of piece that guarantees across everything. But you can still pick .NET languages, you can still pick C++, we now have CX, to extend that as well. Or you can write WWA, which is the Windows Web Application. Did I say that right?
Yeah. So there's completely native apps, universal Windows apps, but written using HTML and JavaScript.
That's right.
But still using our great controls, and it's classical, Windows mobile app experience.
Obviously, I would use DirectX if I'm writing a game or something that really has to perform well on the screen, and maybe I can easily have DirectX in my .NET application, and I can use XAML exposes it that way for us. But I can also go straight over to C++ for performance. Okay, but we have one extra thing that I think is worth kind of mentioning here, right?
Yep.
These bridging technologies that we introduced at Build.
Yeah. So these have only been introduced. We haven't got. We're not ready to talk about these in a lot of detail at this time. Mm-hmm. So we're just going to introduce them into this MV8 and position them compared next to our native technologies.
They are delivering Windows apps, right? These aren't emulated apps or something like that. And they do actually rest on the universal platform, so they still get those APIs and they can still interact and have a rich experience for the user. But they're using the technologies of these other platforms that are bridging into Windows for us.
Yeah, it's a way of you bringing the skills that you know and love, the existing skills which are primarily used for developing for other platforms, but using them to create Windows apps.
Yeah. If of all of them, I'd like to point out the Win32 desktop side of it, that I can take an application that I've written in WPF that is an incredible application, and I know that it runs my entire business, or maybe it'd be valuable for me to sell this. I can, using these bridging technologies, move it into the store and start monetizing it and sending it through the store. It handles all the distribution. It handles the updates. It's magical.
Yeah. So you're converting it into an AppX, so we can distribute it through the store like any other mobile app, and you've got all the great updating technologies. It also does runs it in a virtualized environment, so you're avoiding, you got it like its own private hive of the registry, so it runs just the same as it always did, but you're insulating it in a way that it can run, be distributed through the store, and can run it can be uninstalled as well, so it's a lighter weight of installing these onto a Windows system.
That's right, and it kind of keeps us faithful to that mantra around the store of users won't regret installing an app from the store. And I've regretted many apps I've installed from the store, but that's usually because they aren't the app I expected them to be, not because they wreck my machine. That's really what we're talking about. The apps from the store still have this sort of sandboxed guarantee so that the user is protected, both their machine and their experience. Okay, so these we talked about them, and I think what is important to say here is not just that they exist, but why they exist. And bridges, they just bring more apps to the Windows platform, right? We have, I don't remember, I think we hit some number, 300,000 apps in the store or whatever, but there's still a handful on other platforms that we'd love to bring over. This just narrows that gap so that it's easy to do. The barrier of entry into the Windows platform is simple if you already have an app written on another platform.
So they're designed to allow you to bring the code that you've developed elsewhere and to get it working and create a great experience for Windows users as well, using the skills and technologies that you love.
So a Windows developer has a special situation. Their situation is they're writing an application that can really span the breadth of devices that is gigantic. And you might even want it to be that way, and if it's a very straightforward one. And so there are some best practices, there are some techniques that we're going to walk through, and we have modules dedicated to each of these. But we want to just cover the concepts real quickly, and it starts around UI design. So we have this idea of adaptive design. What is going to happen to your UI so it looks great on a phone, but it also looks great on a television?
Yeah.
Right? That could actually happen.
It can actually happen.
And so we have this idea. We have 3 steps that your application you're going to go through. And so maybe you'll choose just one, maybe you'll choose just 2, or maybe all 3 are right for you. So the first is around responsive design, and we've done this as web developers, whereas as things resize and shape, we build things with percentages, and we don't have specific pixels in their width or their height, and so everything looks really great. And so that's the first approach that we would just expect. And so sometimes even desktop developers stray from that by mistake, right? And they make it so it's hard to resize. But the other is adaptive, and so we can listen for those changes as it goes to portrait mode, as it gets more narrow. Whatever it is we're doing, we're going to rearrange our screen just a little bit to make sure things fit the way they do. And more advanced websites out there, they do that as well. We've seen that sort of thing happen. And so users are already accustomed to it, but even better, we as developers are already kind of accustomed to how to do this as well. The final is this tailored approach, where I sniff for that device family, right? This is a mobile device. So I know it's going to be touch and immersive. I know that it potentially even has a phone connected to it. So I'm going to write a special UI just for that, because I have another special UI just for IoT and the way that it appears on a headless IoT, which of course wouldn't appear at all, would it? And those, anyway, so however it is you've written them, right, you write them as specific rather than making them so that they adjust. That's the tailored experience, and it's totally okay as well. So that's for UI. And so here's an example of the Skype app, and sort of how this is just one app. I mean, especially our first-party Microsoft applications, they're one app across multiple devices. And you can see how it doesn't look the same. I mean, if nothing else, just the hang-up button is in a different location. And anyway, things just don't look the same when they go from one to the other, but that's because it's able to adjust that design.
But this is still one app adapting across the different screen sizes.
That's right. And another one would be tailored design. And so here's the calendar application. And it's not just rearranging. It's not just making things a little bit smaller or larger. It really is 2 different UIs, one built for phone, and then another one built just for the tablet experience and any other experience that you have. So that's going from the responsive to the tailored design. Now, a quick little shout out on something that is awesome.
How cool is this?
Yeah. It's the fact that now I can take my phone. We announced Continuum for phones at Build. Yep. I can take my phone, plug it into my television, or Miracast it to my television, plug in a keyboard or have a Bluetooth wireless keyboard to it, and interact with it as if it were a PC.
Yeah. Now this will take new hardware, so we're looking at the next gen of phones. So we've said that this will be available soon. So the beauty of this continuum idea, and it works across laptops, so convertible PCs as well. So like the Surface, you can take the keyboard away, and it operates completely as a tablet. So there's a continuum experience between a laptop experience and the tablet experience there, and we're extending that to phones as well. So we see an interesting new future where you have admittedly probably a high-end phone that will be able to drive a second screen, and you will get this experience where the phone is driving a big screen. So again, this really drives home the need to have adaptive apps, because you could start off thinking, oh, I'm just writing
a 5-inch app.
I'm just writing an app for the phone, so I don't need to care too much about an experience for a wider screen. Not anymore. If your apps are running on the phone, they could end up on a big screen.
That's right. Especially in mobile-first cultures, where you may not even have a PC. These types of phones are going to be. It's a game changer, really, where you can treat them as if they are your PC just by going over to a device and casting to it, or actually plugging.
Well, you can see people traveling. They're traveling with. They might in the past have taken a laptop, a tablet, and a phone with them when they're traveling. Maybe they just take the phone now, and then they connect the phone up to the TV in the hotel room, and you've got.
Who are we kidding? We would never just take the phone. No, I can't even just bring one laptop. I got to bring all these devices, wires like crazy. It's a rat's nest in my bag.
See me going through airport security. They say, "Have you got a PC in there?" I go, "Yeah, 1, 2, 3." Yeah.
Well, I try and pull this. This is a touchscreen, so it's a tablet. I shouldn't have to take it out. They'd say you can leave your tablets in, but that doesn't work.
Well, yeah.
They always pull it out. It's the battery, I think, that does it. All right, so that's the UI. So you have to be special and thoughtful when you build out your UI, depending on what devices you choose and what devices it might end up on, because choosing the phone does mean you could end up on a television. But let's forget about the UI. What about that underlying piece of interacting with code that's not there, right? We have this ability now to test to see whether or not that the API is available, because adding the SDK gives us the API, but instead what we're really asking is, can I interact with it? So we have adaptive code.
So this is going back to what we were talking about a bit earlier, where we have the core universal common API set, which is this, in Jerry's case, 86% of everything he ever wants to do.
I've had a great experience.
Yeah. But then that remaining 14%, you are calling out to device family specific APIs to light it up on a phone or an Xbox, do something a little bit different on those devices.
That's
and
right.
This is what we're talking. This is where you need to use adaptive code to make sure that the code runs on the device where it was intended to run.
That's right. Well, let's dig into this just a little bit more. So the first thing is, of course, just conceptually, users love apps that work great on all their devices. And this doesn't say users love apps that look great on all their devices. I mean, we just assume that your application is going to be usable and lovely on every device, right? We want to delight our users. But we also want the code to work properly as well across all the devices it might end up on. Now, how do we do that? Well, one of the ways is at runtime, we have the ability to test for different capabilities by using the new API information methods, right? There's a whole bunch of them, but probably the one we'll hit the most is type present, where we can go in and specify a specific namespace. In this case, in this sample, it's just the hardware button, and we're saying, are the hardware buttons here? Now, that's not going to return true. The APIs will be there, by the way, because we have to have this compile. But it won't return true, because it's basically saying, yeah, the APIs are here, but don't try and use it because you're on a HoloLens. And there is no back button on a HoloLens or a camera button on a HoloLens.
So the point is, what we've got is that when you add an extension SDK, and we'll look at this a bit more in a minute, but you've got the metadata for all those methods. So it will compile, and you can ship that binary to every device family. But if you try and ran that hardware buttons on a HoloLens, well, you'd get a type load exception, because the binary kind of is trying to call an API that just isn't there on that device. So this is why you use this pattern, which we call a adaptive code pattern, to gate calls to device family specific APIs to make sure that they only run where they're intended to run.
Yeah, that's right. And it's great that we can do this at runtime. This is not a pound if. No. And it's different than a compilation pound if. So that's where I say pound if this variable, then build this binary, else build this binary. But see, that creates multiple binaries, and that's not our goal. Our goal is a single binary. That's why we can do these runtime tests instead, and that's the reason we have effectively what end up being empty APIs when you're on a device that doesn't support it.
Yep.
And so we test to see whether or not it's empty. So maybe a graphic will help describe it a little bit better. And so let's just start with, we have 3 devices, or any number of all the devices that Windows can now run on. And we also know that we have on each of those the Windows core. So now they're all the same as far as the way that they interact with the hardware, the way that you interact with them, I/O and stuff like that. But then on top of that, we then have our UWP. And so this platform that we have on top of it, you can see the little circles, and those represent all the different contracts that make up that platform. So we've composed a platform, whatever it is that we're targeting, and those are so this is where we begin, and this is just the default set of APIs that we know will be the same across everything. But now I want to extend it. And so when I interact with a desktop, it has its own SDK. When I interact with mobile, it has its own SDK. And when I interact with Xbox, it has its own SDK as well. So here you go. These are just representative of the different SDKs for each of the different types of devices. Now the problem is, as soon as I reference the desktop SDK and I try and run on mobile, it's not there, and so I can get a failure. This is the way that it fixes it. It creates a sort of, perhaps shim is the right word, a kind of an empty set of APIs that allow them to be present on every device, even though they aren't implemented on any other device.
Yeah, it allows the code to be compiled, expecting those APIs to be present, so we can ship that binary.
That's right.
The problem only comes at runtime when you try and actually execute that API, because that's where you'll get your type load exception on the wrong device family.
That's right. You could end up with a lot of if statements and checking to see if this is there and this is there and this is there. And to be honest, there will be some applications where that is just a reality. But thank goodness that the mechanism is there for you to be able to use it. So now you can actually have this experience for the user. But for most developers, most applications, there's going to be another scenario where they don't actually try to deliver to every single device. Instead, they choose which device family they go to.
Yeah, so this is a very interesting statement. What do we mean here by which APIs you can call freely? Well, if you can think about when you're creating a Windows 10 app, you've got a number of different choices you can make about where your app will run. You could choose just one device family to target. You say, okay, I'm just building a HoloLens app. That's what I'm doing, and it's only going to run on HoloLens.
Yeah.
Or I'm only going to run on phone.
You won't have to do all those gating checks if you're only running on HoloLens.
You can just add the extension SDK and call those APIs freely. You don't have to care about, because you know it's not going to run anywhere else. So you've made that choice. But as soon as you go beyond that, you say, okay, I'm actually going to create an app that will run, and this is probably going to be the general case. I'm going to create an app that's going to run on the desktop device family and the mobile device family.
Right.
And we're going to create the adaptive UI to make sure we've got a great UI experience on both desktop and on the smaller screens. And in occasions, we're going to maybe add a reference, and you don't have to do this. If you don't want to use any of the light up APIs, you don't need to add a reference to the extension SDK. But if you do, then you can make a great experience on those devices, calling out to features that are specific to mobile in the one case or desktop on the other.
Narrowing your scope of what devices that your app is going to run on will simplify your UI, and it will also simplify your code. But it could complicate your future, because if you're not thinking far enough ahead to, eventually I do want this on Xbox because I want to expose it and I have this sort of media. If you're not doing that, you're going to have a lot of code to come back to and start gating. So be sure only you know your app, right? I don't know your app. So you get to make the decision of where's the future of this application. Do I need to write this as kind of defensive code now, or should I wait till later to do it as well? Yeah. There is something about getting to market quickly. So it might pay off to go ahead and take whatever steps you need to get initial success. But at the same time, think this through. If you're writing a voluminous code base, you don't want to paint yourself into a corner.
Yep. So we'll go into more detail on the adaptive code story in another session in the MVA.
Now, one nice thing that developers have, thanks to Microsoft, is they have a simple, unified development environment, fully integrated, right? This is Visual Studio, and it's absolutely fabulous. So the Visual Studio IDE, every type of project. Are you creating a game? Are you creating HoloLens? Are you creating desktop, whatever it is, you know that Visual Studio is your starting point. And it's so extensible, of course, as well, so you can add all of these things. All the developer tasks that you do, if you're managing bugs, if you're doing a sprint planning, if you're developing, if you're debugging, if you're testing, all of those things, again, rolled into Visual Studio as a single place for developers. It's really beautiful. And then, of course, whatever language you choose, if it's C#, C++, you're writing everything in JavaScript and HTML, whatever it is, all of that, Visual Studio again. And of course, we have Visual Studio Online, which we know now, Andy, really isn't a web-based Visual Studio. The name just sort of makes you think it's a web-based Visual Studio.
It's lifecycle management tools, it's source control, it's a bunch of stuff in the cloud to make your life easier.
If I were in charge, I would have called it Visual Studio Services, all the stuff that feeds into it. But I'm not. It's so clear. All right, let's talk about our new compiler. We have Roslyn, which ships with Visual Studio 2015. It shipped also with 2013 behind the scenes. Nobody knew what was going on. It got a couple neat things like CodeLens and stuff was powered by it. All written in .NET, which is terrific. And it is enabling so many new features in Visual Studio that you almost don't recognize Visual Studio anymore because of it. Another piece that ships with Visual Studio is Blend. We saw that earlier in our demo. A full developer's IDE. If you're a XAML developer, you can just live there. Finally, you can do all your coding, your debugging, all of these things that you just couldn't have before. You always had to go back to Visual Studio. Feature after feature is introduced. Meanwhile, all of the bread and butter that was part of Blend is still there as well. So all that UI experience, storyboarding, visual states, it's all there also. So you can do some pretty amazing things. 3 versions of Visual Studio. Probably the one worth calling out is Community Edition. Completely free.
Yeah. And the features of Community is like it's a really great featured edition of Visual Studio, kind of equivalent to, if those of you who've used it, older editions of Visual Studio, it's kind of like the professional edition from
that's
previous.
Right.
Yeah, so it's a really good deal.
Of course, now we've reused the word professional for what premium was.
Yes,
we changed Ultimate to Enterprise.
Yeah.
One that's not in this list is the Express Edition. And the Express editions of Visual Studio are still there as well. And the reason they're still there is some enterprises want to tinker with something that invalidates the Community Edition's license. Yeah. So Community Edition is for you and for me to be able to use on stuff. It's not for extremely large companies to not have to buy Visual Studio because that's not what it's designed to do. It's meant to enable developers. It's worth pointing out the Microsoft Developer Network. So this is MSDN. There's free and a paid subscription to it as well. And so this is where you get all the library and information. You're wanting to try out Windows 10, you go to MSDN to start learning all of these pieces. Another place you might go to learn is Microsoft Virtual Academy. Turns out there's a website out there called MicrosoftVirtualAcademy.com, and you're on it right now, or you might be on Channel 9, and watching courses just like this. They have a catalog that's just off the charts. And then the subscription to MSDN is how you get all of our software for development purposes and just as all you can eat, every operating system and everything else. A Windows 10 device needs to be unlocked in order for the developer to use it. Now we have introduced a developer section in the settings where you can go.
Well, this is great.
On and
yeah,
off.
This was great because in the past, to unlock a phone, for example, you had to run a separate tool that came in SDK, and that wasn't particularly discoverable.
No.
And unlocking a desktop device for sideloading, was kind of tricky. And
that's right.
Now, actually, it's just in settings on the device, so you can go right into any Windows 10 device and right down the settings. You can just choose to developer unlock it, so you can sideload your device with the apps that you're creating in Visual Studio and get them tested really, really easily.
Another great thing is the desktop now, you can sideload by default, and then the organization will shut that off and close it down.
Yeah.
It was the opposite in 8,
That's
where
right.
you couldn't sideload. There was special licensing and blah, blah, blah. All of those things are gone, and it's nice. All right. Where can I develop Windows 10 applications? I think a lot of developers are going to be surprised to learn that not only Windows 10, but they can also build Windows 10 applications if they're running Windows 8. Of course, it's going to require Visual Studio 2015, and you won't have the full fidelity. Your debugging experience might actually require a Windows 10 device, but nonetheless, you can use that and interact with it in a way that was kind of unheard of before.
Yeah, that's right.
Pretty neat. All right, so a neat thing to talk about is the idea that managed languages like C# are now more efficient than they've ever been, thanks to .NET Native.
This is a really cool new feature. The latest, I mean, we've been doing this with Windows Phone for a while, and we keep improving the efficiency of our compilation and the way we distribute apps and how they're run and this sort of thing. But .NET Native now essentially means that we are compiling everything that you submit through the store is compiled in the cloud.
That's right.
And what we are shipping to the end user device is the bits and bytes just ready to run. So there's no JIT compilation happening at all on the device anymore.
Yeah.
So just-in-time compilation, which is a very flexible way of shipping a tokenized code to a device and having it turned into machine code right there on the device, but that comes with trade-offs and delays.
Well, I think it's worth saying that we're talking about Windows apps specifically. We're not talking about WPF apps or anything else right now. We're talking about Windows apps. That's where .NET Native is today. It also means that when you come down to my device, I'm pre-compiled. And it means that I get a small .NET bootstrapper attached to it. So I get things like garbage collection is still part of it. But unlike a regular .NET application like WPF, I'm not running inside a runtime. I'm running straight against the metal, and I'm using the same C++ optimizer as C++ developers enjoy. And so I get that sort of optimization for speed and things like that as well.
Yeah, and so the deal here is every Windows app will be compiled with .NET Native. So this performance improvements and the benefits of this are going to be right across the board.
Yeah, that's right. Some of the real benefits, and these are just some numbers that we have right now. And the team got these actually by compiling apps already in the store. Right? This is going to be compatible with a lot of stuff. And just faster startup time, less memory that you're using. It's pretty incredible that you can do this in the first place. And .NET itself, we go back to this idea of cadence.
Yeah, so .NET Native is a technology that helps us to manage this kind of new world of frequent updates. Again, going back to the idea that in the past .NET was shipped, and latest update was shipped along with Windows. So Windows 8.0 came out, and we had .NET Core 4.5 was shipped along with it. And then 8.1 came out, and we had .NET Core 4.5.1. So we always were waiting with .NET for the next big update of Windows to go out before we could kind of ship to you the benefits of the new features that we wanted to put into .NET. And tied to these big release, these kind of moments in time, which was constricting. And we want to get stuff out quicker. So now, with .NET Native, what happens is that we statically link your app in the cloud. So you're statically linking against all the .NET libraries and everything you need. So what the user gets and installs on their machine is everything, all the self-contained, everything it needs, all its dependencies is all there. So it means that the platform can be updated, and your app doesn't break because it's not got any dependency on the underlying platform. Everything's there.
Does this seem just a little bit sophisticated to you, and you're not quite sure what we're talking about because .NET Native is obviously a complex thing? I'm glad to tell you that there's build sessions dedicated to it, and you can go learn from the people who actually built and designed it. And it is an amazing kind of an engineering marvel that Microsoft has been able to pull it off.
It is, and the benefits are great. You're going to get great improvements as a consequence of this.
One last thing I think is worth at least mentioning is the idea of template 10. And so template 10 is a new a blank project template, and the new project won't be completely blank. It includes some empty folders and some guiding conventions, much like the MVC project does inside Visual Studio, so that you sort of know where to put things, but it doesn't force you to do them that way. And so there's a new template 10. Andy and I are involved in it right now as well. It's going to be the base of pretty much every demo we're going to do in these next 3 days. And so as you see it, you'll kind of feel it out and see that it's really, really nice. The next version of Visual Studio, or this version, I guess, Visual Studio 2015 only ships with blank itself, and it's really just a raw blank, right? Where it's really not giving too much guidance. And so it'll be nice to have this as well. It doesn't solve every developer's needs. We know that. It solves about 90% of the developers out there, their needs. They're going to be that 10% outliers that they're going to need to do their own thing. But those who are just looking for some simple guidance, it's going to be there as well. You can contribute to Template 10 by going to akams/template10. It's in GitHub, and you can submit a pull request, or you can just go get it yourself right now. This is going to be on the same track as Windows 10, so it's not available yet in the gallery, but it'll be publicly available in the gallery at the same time frame as Windows 10. So looking back, we talked about the single platform of Windows 10, what developers have to look for, and what do we mean when we say universal Universal Windows Platform. We'll edit that out in post-edit. That'll be fine. And then the developer experience and all the tooling, the cool stuff that's going on with .NET Native, and then this idea of Template 10, the new file new project is a template that we're using here, and seeing going on into the future as well. Cool. So we're going to take a 10-minute break here and come back to the next session, Andy, where we can talk about all kinds of cool things. We're going to really begin just hammering in on XAML, a lot of the changes that you've seen, that we have seen, and are starting to fall in love with in XAML as well. So we'll see you again in 10 minutes, Andy.
Okay, see you soon.